Assalamu alaikum. The topic in this lecture we have to discuss is the determination of equilibrium constant. For this topic, we have to discuss a particular equation for the ethyl acetate equilibrium. For the ethyl acetate equilibrium, we have to consider an equation. This is what is the acetic acid is reacting with the ethyl alcohol and is forming the ethyl acetate molecule along with the water. Since we are discussing about the equilibrium of the reaction, so first we have to discuss is the moles at initial state. Since the number of moles are unknown, so we just have to consider one of the variable. This is what is A. And for the ethyl alcohol, we have to consider one of the variable, that is what is the B. Since this is the initial state of the reaction, so this means there is no product. So at initial state, the number of moles of the product means to say the ethyl acetate and the water are 0. Then the point is to be discussed is the moles at equilibrium stage. In order to discuss about the moles at equilibrium state, we have to consider the moles at equilibrium. We have to consider a kid who has $10 in his pocket. That is what is the initial amount. And suppose he goes outdoor where he expends $3. That is what is the consumed amount. And when he comes back, so the question is, what is the remaining amount he has? You must be answering the $7. But I would say the amount he has in his pocket is 10 minus $3. Of course, these both answers are correct. So means to say these both are same. So here what we get, the remaining, the $7 is equal to the 10 is the initial dollars he had, and the $3, that is what is the consumed. So the formula is the remaining is equal to initial minus consumed. Just keeping in mind this particular formula, we can find the moles at equilibrium. So over here now we can consider the moles at equilibrium state is the initial minus consumed. So initial is A. So how many moles of acetic acid has been consumed is unknown. So we now have to consider another variable, that is what is the X. So what is the remaining moles at equilibrium is A minus X. Since there is a stoichiometric ratio between these two is 1:1. If the 1 mole of acetic acid is consuming, so the 1 mole of ethyl alcohol is also consuming. So since the X mole has been consumed of the acetic acid, so of course the moles of ethyl alcohol that has been consumed is X moles. So overall, the moles at equilibrium state of ethyl alcohol should be B minus X. Now according to the stoichiometric ratio, the same is over here, the 1 mole and the 1 mole. So of course, the number of moles formed at equilibrium for both of these products are X and X. Now turn this to right is the concentration at equilibrium state. When we have to write the concentration at equilibrium state, so we must need to know the volume of the container where the reaction is to be produced. Where the reaction is to be processed. So over here, we are assuming the volume 1 dm cube. So now what is the concentration over here? That is the moles divided by the volume. The moles are A minus X and the volume is 1 dm cube. So since that is the volume, so what is the concentration is A minus X over V. What is the concentration of the ethyl alcohol at equilibrium is B minus X over V. For the ester it is X over V, and for the water it is the X over V. Since all the concentration at equilibrium are known, so we can easily now can put the formula according to law of mass action. The formula is known to us is the Kc is equals to concentration of ethyl acetate in the water, in the denominator concentration of acetic acid and ethyl alcohol. Now we have to put the concentration of all these reagents in the formula. So over here, for both the products, the concentration is X over V, and since we know the V is 1 dm cube, so this is what is the X over 1 multiplied by X over 1. Over here, for both the reactants, the respectively the concentrations are A minus X divided by volume, that is 1. This is what the B minus X over 1. Finally, what we get over here is the X square. In the denominator, A minus X, B minus X. So this is what is the Kc value. Just by knowing the initial moles of the reactant, that is what is the A and B, and the consumed moles or the number of moles formed of one of the product, we can easily calculate the Kc value. Now for the next question we have to proceed is the hydrogen iodide equilibrium. For the hydrogen iodide equilibrium, we have to consider an equation. This is what is the H2 plus I2 giving you 2HI. The difference is over here, the 2 moles of HI is present in the product. But we have to proceed with the same steps. First, it is the moles at initial stage. Says once again, the number of moles of the hydrogen is unknown, so we have to put a variable over here. It is A moles. For the iodine, it is B moles. And since the reaction has not been processed, so the product must be 0. Now the moles at equilibrium state, of course, 1 mole of the hydrogen is consuming, so the remaining moles after equilibrium for the hydrogen is A minus X. And for the iodine, the same number of moles would be consumed, that is X. So the remaining moles of iodine would be B minus X. And over here, the product, since the 1 mole of hydrogen, with respect to hydrogen, what we can say, the 1 mole of hydrogen is producing 2 moles of hydrogen iodide. If 1 mole of hydrogen is consuming, so the 2 moles of HI would produce. So we are considering the X mole has been consumed. So of course, how many moles of hydrogen iodide should be formed? That is the 2X. Now we have to proceed for the concentration at equilibrium state. This is the concentration at equilibrium stage. While we are talking about the concentration, we must need to know about the volume. So this is what is the 1 dm cube. So putting here all the values, the moles divided by the volume is 1. This is what is the moles divided by volume, that is 1, and the same is over here. So these all are the concentration at equilibrium. So we can now put the law of mass action. According to law of mass action, the formula is over here. This is well known to us. Now we have to put the concentration of all these reagents. Over here, there's the concentration of HI. This is what is the 2x over 1. So of course, this is 2x and whole square. Concentration of H2 is A minus X. Concentration of I2 is B minus X. Now simplifying the values, so the Kc value is equals to 4x squared in the denominator, A minus X, B minus X. In the same way, if we know the initial moles of A, means to say the hydrogen, and the initial moles of iodine, that is what is the B, and the consumed moles or the number of moles formed in this reaction, we can easily calculate the Kc value. Thank you very much.